We talked before about finding the intercepts of a graph, and these are the points where the graph cuts the axes, the x-axis or the y-axis. The x-intercept of a graph, or the x-intercepts, are the x-coordinates of the points where the graph crosses the x-axis. There may be more than one, and we can find these x-intercepts by setting y equal to 0, because at these points y must be 0, and then solving for the values of x in the resulting equation. And we can do the same thing for the y-intercepts. These are the points, the y-coordinates are the points where the graph crosses the y-axis. And to find these, we set x equal to 0 in the equation, and then solve for the values of y that give us a solution to the equation. So for example, suppose I take this equation and I want to find the x and y intercepts. Let's start with the x-intercept, and that's at the point where y equals 0. So this says at that point, whatever x is, x squared over 9 plus 0 squared over 4 equals 1. And that tells me that x squared over 9 equals 1 at that point. And this tells me that x squared equals 9, and there are only two possibilities. X equals plus or minus the square root of 9, or plus or minus 3. And so at these points where x is 3, or minus 3, the graph of this equation crosses the x-axis. What about the y-intercepts? Well, these are at the points where x equals 0. And so at these points we have 0 squared over 9 plus y squared over 4 equals 1. So that tells us that y squared over 4 equals 1, or y squared equals 4. And taking the square root of both sides, we get y equals plus or minus the square root of 4, or plus or minus 2. So we see that the graph crosses the y-axis with those two y values, plus and minus 2. Now what about the graph of this equation? Well, this is an equation which gives us something called an ellipse, which is a bit like a flattened circle or an egg-shaped object. And how might I graph it? Well, I'm going to try to solve for y in terms of x. So this equation, I can rewrite it, and I get an equivalent equation, y squared over 4 equals 1 minus x squared over 9. And of course the graph of this equation is exactly the same as the graph of this equation. And this means that y squared equals 4 times 1 minus x squared over 9. And for any given x value on the graph, I must have y equals plus or minus the square root of the right-hand side, which is 2 times the square root of 1 minus x squared over 9. So this is actually two equations, y equals plus this and y equals minus this. And any x and y which satisfy either of these two equations satisfies my original equation. So the first thing to note here is that I can't have the square root of a negative number. So if the absolute value of x is greater than 3, then 1 minus x squared over 9 is less than 0, and the square root of 1 minus x squared over 9 does not exist. And so that means I can find no y value to go with this x value, which gives me a solution to either one of these equations. So no solution to the equation, the original equation, as the absolute value of x greater than 3. In other words, all solutions have their x values between 3 and negative 3. Now we know there is a solution with x equal to plus and minus 3. Two solutions, x equals plus 3, 0 is a solution, and x equals minus 3, 0 is also a solution, because these are the x-intercepts of the graph. So the graph of this is concentrated between the x values minus 3 and 3. And so to get some idea of what's going on, we're going to plug in some of these x values, minus 2, minus 1, 0, 1, and 2. And we know that for each of these x values, there are perhaps two possible y values that go with them to give us a solution to the original equation. Y equals plus the square root of 1 minus x squared over 9, and y equals minus the square root of 1 minus x squared over 9. Both of these points give us a solution to the equation. So what are the possible y values that go with minus 2? Well, they're y equals plus or minus the square root of 1 minus 2 squared is 4 over 9. And that's plus or minus the square root of 5 over 9. And that's equal to plus or minus something that's roughly 1.49. Actually, I'm missing a 2 here, so let me put that in there. And that's plus or minus 2 times the square root of 5 over 9. And so I check this out in the calculator, and this is plus or minus 1.49 roughly, approximately 1.49. So I actually have 2 points in the graph here. Negative 2 with the y value 1.49 gives me a solution, or approximately 1.49, and negative 2 with negative 1.49 also gives me a solution. What about when x equals negative 1? Then y, there are two possibilities for y. Y equals 2 times the square root of 1 minus 1 over 9. And that's plus or minus 2 times the square root of 8 over 9. And that turns out to be plus or minus 1.88 roughly. So with this value x equals minus 1, I get a point roughly at with y equal to 1.88, and another point on the graph where y equals negative 1.88. When x equals 0, y could be plus or minus 2 times the square root of 1 minus 0, which is just 1, and that's plus or minus 2. And I knew this was true already. These are just the y-intercepts of the graph at y equals plus or minus 2. Forgive me. That's a minus 2. And now when y equals 1, or when x equals 1, y equals plus or minus 2 times the square root of 1 minus 1 over 9 again. And that's equal to approximately plus or minus 1.88. So I get 2 points, 1, 1.88, and 1 minus 1.88. And when y equals 2, or when x equals 2, pardon me, when x equals 2, y is plus or minus 2 times 1 minus 4 over 9. I've already calculated that. That's plus or minus approximately plus or minus 1.49. So I get 2, 1.49 is on the graph, or approximately 1.49, and plus 2, negative 1.49 is also on the graph. So this gives me a bunch of points on the graph, and now I can draw a picture. I know that my graph is concentrated between -3 and 3. And the y values here are between plus and -2. And when x equals -3, I see that y equals 0. These are the x-intercepts at plus and -3. When x equals -2, there are two possible y values, plus 1.49 and negative 1.49. So I have 2 points on the graph. And when x equals -1, I get y equals 1.88. And another possibility is y equals negative 1.88. Then I have my y-intercepts at 2 and -2. And when x equals 1, again I have y equals two possibilities for y, 1.88 and negative 1.88. And when y equals 2, I have two possibilities. When x equals 2, I have two possibilities for y, 1.49 and negative 1.49. So my graph looks like this when I join the dots. And it is indeed a squashed circle. These ends should be smooth. It shouldn't look quite as much like a football as it does. And this is called an ellipse. And it's a special example of something called a conic section. If you slice a cone at an angle and the slice goes through both sides, then the exposed part of the cone will look like this, an ellipse.